It's my honor to introduce some of my friends and Philly crew here, and we're all outstanding professionals in the field of architecture, sustainability, construction. So I'll start with Lauren Thomsen, principal and founder of Thomsen Design. Lauren comes with a wealth of experience in historic renovation, new construction around Philly. She's contingent faculty at a number of local universities, and I've had the honor and joy of serving in her studios. And hearing her speak, I can really tell you that Lauren's got an amazing ability of distilling and communicating complex architectural topics. Welcome, Lauren. We have Matt Gindlesparger, a registered architect and CPHC working for Thomsen Design, contingent faculty of architecture at Thomas Jefferson University here in Philly. I've met Matt numerous times through studio reviews and at various Philly architecture related events. Matt has a keen eye towards architecture details, performance, and has a history of next generation building systems. So if you ever want to talk about energy harvesting facade systems, talk to Matt. John Roderick, co-founder of Scribe Design, third generation woodworker, and has a BA in environmental studies, geography, and urban studies from Temple here in Philly. John has a history in home renovation, adaptive reuse, and is passionate about building projects that honor the past while focusing on the future. I know John is a friend and neighbor who is an active member of our community and helping manage our local community garden. Good to see you again, John. And Ralph Loielo, co-founder of Scribe Design and 2 decades of experience in design and construction. Ralph's a native Philadelphian, lifelong environmentalist, and with a BS in architecture, MS in sustainable design, and a certified passive house builder, Ralph has a rich background in sustainable design and construction. So knowing Ralph for several years, I admire his attention to detail, his ability to see a larger picture, and his get it done right attitude. He's never afraid to get his hands dirty, and I can say personally he's given me the much needed push in the back to tackle some of my own projects at home. So those are your presenters. Hope you enjoy their presentation. I think this is going to be a great addition to the Passive House Accelerator Live archives. This would be a really great project. So without any further notice, hand it over to the presenters.
Hi, everybody, and thank you for coming tonight. Thank you to Passive House Accelerator for having us on. It's such an honor to be on the show. And we're really thrilled to share this project with you. Next slide, Matt. So the first thing we wanted to do is introduce our project team. We've had the really fortunate and unique experience of having, as architects, having both the GC and the owner, which is Ralph, of the property, come to us with aspirations of building a passive house, and being able to work with him from the conception of the project all the way through construction as we are currently. And it's been a great experience and a real kind of wonderful team effort so far. So the site context of the project is located in Northern Liberties in a very dense neighborhood on a small infill lot. Next slide. As you can see here, we're on Orkney Street, and the street is barely 9 feet wide. So we knew from the get-go during design this was going to be a challenge, both in terms of the density of the lot and neighborhood, but also thinking about construction. We knew from the outset that it would be kind of a tight site and a constrained construction conditions. Next slide, Matt. So the site is uniquely positioned immediately adjacent to a park called Orkney Park, which is a really lovely green space in this urban environment. It's only 18 feet by 43 feet deep, and our building is only 36 feet deep. So it's a total of 1,672 interior square feet, which is not much. And that does exclude a garage, which is located within the massing of the building. But the design goal from the beginning was to maximize the buildable footprint and living space on this small site, However, we also wanted to be respectful and kind of mindful of our neighbors to the south and the park. And in Philadelphia, there's this ubiquitous condition of a massive blank party wall that is really unpleasant to look at. So we use that, and also the fact that our south elevation actually has solar exposure, or to gain some solar exposure through windows. We stepped a portion of that elevation back and off the party line, sacrificed some interior space, and then and also use that as an opportunity to create an outdoor space and a kind of a change in materiality, which would offer a nicer kind of view from the park to the building, and a better urban condition, we'll call it. So it's, here you can see that in the elevation. Sorry, Matt. Looking south would be the view kind of from the park. Next slide, Matt. And just a rendering of the project, as you can see. The exterior materials that are being used for the project are corrugated metal and also a thermally modified oak slat, which we'll get into later in the project, or sorry, later in our presentation. Next. So here you can see some images of the site again, which is really very constrained. In the city, we're dealing with immediately adjacent neighbors and shared property lines. A site which you can see Ralph's truck occupies a large majority of, and also, difficult kind of turning radii and other constraints. Here, next slide. Which, as you can see in the plans, yields a rather kind of a small footprint that, despite the fact that it's small, it's a 3-bedroom home with, multiple living spaces. It feels really open. And we were really happy that we feel like with the design and the interiors, you can actually, you can feel that it feels really well proportioned, and it just will feel, it won't feel small, it'll feel really kind of like nice and right. You want to show the interiors, Matt? Those are just a few views of what's to come. And Matt, you want to jump in?
Yeah, so, along with the sort of like planning complexity of just kind of like dealing with the horizontal layers, the sectional complexity also kind of makes itself very evident very quickly. If one of the sort of mantras of of kind of designing and building to kind of high performance standards, where we have all these sort of like material intersections, it is very helpful to kind of maximize simplicity. But when we have such tight and challenging site constraints, that's very, very hard. So we really had to sort of jump into a lot of different complexity from a form generating perspective, from a performance perspective, from an approvals perspective. So here we see where and how the garage is kind of like cutting into sort of our building envelope, and we have some kind of changes in level, and all of this sort of setback that we're looking at the sort of south elevation is towards the end of clawing back some solar access and solar gain along the south. So with that, where we have all of these different surfaces and different sort of conditions, along with that comes a huge array of a kind of assembly types, right? We would love to not have this many distinct assemblies in the project, but here they are. There's so many different conditions. We're kind of oscillating between exterior walls, fire rated exterior walls, party walls, subground, below grade conditions, up against garage spaces, etc. So all the while thinking through the materiality, thinking through, making sure we get our insulation, making sure we get our airtight, and then also just taking care to make sure the thing can be built. which obviously is a challenge that we'll talk a little bit more about. So, here we're going to kind of like go through some of the details and kind of like talk a little bit about, how it was sort of designed, and then how it is executed. We'll hear from Ralph and John. So, here we see, what starts off as a fairly typical foundation condition, but, now we're sort of applying our sort of thermal boundary layers, insulation all the way down the foundation walls. All of our subgrade insulation is 3 inches of EPS foam. And then, also taking care to manage, waterproofing layers, drainage to get everything running in the proper directions. Our air sealing is where it needs to be. Ralph, anything you want to add here?
Yeah, sure. I mean, like I could talk a little, I guess, about the materials that we decided to go for as far as our waterproofing system. It was the first time we did anything like this. We're used to just doing a damp proof on the outside, no capillary break or anything like that. And so, we went through lots of different options. They make the Delta makes a product that you can capillary break over your footing before you pour your foundation, but it doesn't really work well with rebar. So we ended up with a liquid apply product for that, and then we stuck with that same product for the exterior waterproofing. It just gets a primer, and then the Mel roll is a peel and stick, then the EPS, then the drainage board, and then right down into that drainage burrito. I'm sure you're all familiar with.
So, as we all know, like we're talking about building parts that everybody's familiar with. We're just using more of them and in different sort of configurations. So then if we kind of take a look at and we kind of try to snapshot some of our most typical assemblies, our sort of our primary sort of exterior wall condition, starts off as what we would consider kind of a standard 2x6 wood frame construction. Our exterior sheathing with integral weather resistant barrier goes on top of that, and then 4 inches of mineral wool on the outside. That's our sort of continuous insulation layer. The inside stud cavity is dense packed cellulose. And then, the sort of location of air barriers is one that we bounced back and forth and discussed a lot. Where do we want to place that? How are we going to address that in this project? While the exterior of the envelope is an interesting opportunity with kind of integral water resistant barriers on it, that we want, since this was everybody's kind of first shot at a passive house project, designers and builders included, we really kind of wanted to opt for the sort of belt and suspenders approach. So we do have an Intello layer, and our air sealing is internal to the cavity, internal to the wall assembly, and that comes with a lot of sort of nuance with exactly how that membrane system is existing. So those are our sort of primary exterior walls that are exposed. And then we have our party walls, our adiabatic walls, where starts off as wood framing. We are maintaining a layer of mineral wool in between the houses. Important at the edges, at the boundary conditions, but opted to maintain it throughout the field for additional sound attenuation against the neighbor's party wall within the project. And then the kind of horizontal assemblies, Philadelphia row homes, where we do a lot of flat roofs. And so we kind of started in that same direction. A typical wood frame structure. On top of that, on top of our weather resistant barrier sheathing, we've got polyiso insulation as our continuous exterior insulation, and then the framing cavity filled again with cellulose and air barrier to the interior. And then even within the house, we have some sort of bespoke assemblies in the separation between the garage, again, outside of the conditioned thermal area, and then directly above the garage is the kitchen space. So taking on the challenge of, how do we ensure the continuity of our air barrier in that horizontal assembly requires essentially taping and seaming the horizontal assembly above the kitchen. So we really have at every sort of turn in this project is sort of an adaptation of the assembly. And it's worth noting that, and by design, it should be obvious, hopefully, that we really are sort of intending to be able to kind of dry in both directions throughout this project. And then as we sort of move into the sort of punctures and windows and openings and the interaction of windows to walls, our window package is all Alpen windows and Alpen's brand of exterior doors. Those are block mounted in the assembly, and a plywood buck, window buck is extending out past to the outer edge of the insulation layer, so that we can, fit in all of our connections, fastenings, sealing, air sealing, water sealing, and kind of maintain all the thermal continuity that we can. So lots and lots of steps, lots of trial and error in the kind of exact execution of the kind of detailing of these windows. Ralph, John, any nuggets?
I suppose we could sort of really drive home the double air barrier back 3 slides ago. We have the 180 abatic wall, and so one of my major concerns, one of my biggest fears was like, how am I going to get an exterior air barrier at this 80 abatic wall when you pretty much have to build them in sections that are like manable to like lift up into place like a barn raise. So it was just really,
it's exactly what we ended up doing.
That's what we did, and that's typical. But how do you make an exterior shear sheathing sort of airtight? And it's not really all that possible. So that's really, what, we really had to do the interior Intello and really get that air barrier going. So I think that's really all. I think you covered most of that, Matt. Yeah, the challenges of air sealing in the windows and so forth. The outside here, we end up with the air dam and the backer rod and all that. Our windows came with flanges on them. We didn't really
we didn't want a flange.
We didn't want flanges, but we had to order them because the lead time on the windows was like 40 weeks, something crazy. So we just sort of went ahead and ordered them, but then later we decided we probably wanted anchor straps instead. So we ended up with hybrid air sealing. So on the outside, we have air dam, backer rod. On the inside, we've actually taped it with the Profil and the Tescon Vanna where appropriate down into the bucks. So, yeah.
So, and just kind of continuing on a little bit of the kind of trials and tribulations of air sealing, lots of detailing went in at the front end of things, just to understand the conception of how these things might come to be. At us as the designers in CPHC, we spent a lot of time going back and forth with Ralph, well before any dirt started getting moved, to talk about, what materials are we using? How are they organized? How are we going to get them there? To ensure that that detailing was developed that could be kind of reviewed and approved, that actually could be built. And then, as everybody knows, like, as we sort of like really get the rubbers in the road and are met with the challenges of the project in real time, you end up having to try a lot of different things, a lot of different, maybes. What is the best way to kind of address these issues? Ralph, John, you want to walk us through your?
So you see Johnny here. This is our first iteration, number 1. We super concerned about our floor to floor air barrier continuity. And so what do you do here? And we went with Intello, wrapping it up into the rim joist and then taping all the corners up. And that's Johnny.
That's what you see in the
Yeah.
first slide there. So we were practicing our origami skills and wrapping up and taping. A bit tedious, certainly works fine. But we were starting to extrapolate all the corners we had and moving throughout our other horizontal assemblies throughout the project. And we were like, well, let's try another way and at least see how that goes. So, next we moved to this liquid applied Prosecco, our red goo, and we decided to roll that across our entire rim and sill, which was expensive and time consuming as well. Definitely would have gotten the job done. So then we settled on a hybrid, if you want to talk about that.
Sure, yeah, we did a hybrid. So instead of taping our corners, we would roll the Prosecco Red Guard roller grade fast flash into the corners, outside and inside corners. And then we would just roll the Intello up over it while it was still wet. And the Intello would adhere to it, and it's super airtight.
And then we would go ahead.
Faster, way faster.
Yeah.
Yeah. And then we load in our adjacent joists.
Load them in.
Yeah.
And that was something we thought about as we went through the design process, was like the sacrifice of the extra inches of the air cavity, or the service cavity rather. But ultimately we just decided it was worth it to kind of do it right. And like Matt said, just have that assurance that we'd be staying out of there with all of our utilities and the systems.
Sure.
So speaking of systems, our sort of conditioning and ventilation, we're getting what we need out of two Minotaur units in the project. One basement located that is serving the sort of lower basement level plus the primary living space. And then a second one situated at the second level, serving the sort of bedroom floors. And so obviously those, we do a ton of design work at the outset of this thing, laying out, designing, and really kind of spatializing all the components. Again, because we wouldn't typically do this in a project, but with so much at stake from a spatial perspective and so much additional complexity in the building, in the wall assemblies, everything is kind of bigger and thicker. It was helpful. It was very helpful to be able to kind of spatialize and coordinate all of these kind of systematic components, into a model that allows us to really physically see where and how everything is kind of living and existing. And again, we still have to then manifest that, which requires, an on-site whiteboard that we can kind of like work through, the fine grain, parts in hand versions of how everything comes together. And then in terms of energy generation, for PHIUS pre-certification, we included a PV array on the roof for source energy. This is just shy of 3.5 kilowatts of system on the rooftop, and that's how the project sort of started. But then, as it's developed over the last few months, sort of end user has indicated an interest in incorporating battery storage into the project and charging for their electric vehicles. So that sort of got kind of added on and added on to the scope of the project. And here's where actually having that garage space is of benefit, because storing the batteries, doing the battery storage in the garage space, doesn't burden the interior living space with any additional heat loads associated with the battery storage. So, and in addition to the battery storage, there's also smart monitoring and controls of the kind of electrical systems within the project, so we can kind of see what utilization is like, how production, how solar production is going, and how the house as a whole is utilizing the energy that it generates. You know, and so there are so many facets of this project. It has been just going on for forever, right? It feels like we were talking with kind of Ralph a couple of weeks ago. It's like, oh yeah, we started this project in 2020, but actually we started this project in 2019. So we started the design of things because we had to get zoning approvals for variance for garage and roof decks. You know, we had to go through the variance process, and then COVID happened and kind of shut everything down, slowed everything down quite a bit, you know, and all the while we're still trying to keep things moving, doing the design work. The pre-certification process is challenging, time consuming, you know, it's requiring a whole different set of skills. And so this project has really been an exercise of patience. And that patience, you know, kind of takes its way into the design process. It's in the construction process. And sometimes a little bit of time just needs to be taken to allow nature to take its course and sort of do its thing. John, any insight to what it is we're seeing?
Yeah,
here?
you're looking at an American robin here. Fledgling is usually it's about 14 to 16 days. So we did work around them.
That's the first flight. That's that image.
That is an action shot of first flight. I think we
flight.
had two fledglings make their way out. So we see them periodically, and
They're doing well.
And some construction was sort of relocated temporarily to allow this to happen.
I mean, we had to
shifted
do
our facade work to somewhere else to wait for this to happen. So for sure.
But you know, the head flashing could wait there. It was fine. This was how we were getting in and out to the pump jacks anyway. So you know, it was going to be the last spot anyway, right? Didn't slow us down too much.
Not too much.
John's our team birder.
That's right. Proud birder. Yes. Thank you, Lauren.
So, and the project is well underway. Cladding is going up, windows are in. You know, we were on site this morning, afternoon, kind of working through plumbing rough-ins, locations of things, and just kind of continuing to trundle on here in this kind of very exciting project. This really has been incredible to work on, to have the opportunity for this much scope of a project, right? It's kind of got all the bells and whistles and all the fun associated with it from a design perspective, and to also have kind of a great client and contractor partner in this thing has been very helpful. So hopefully everybody enjoyed.